Good morning, good afternoon, good evening, wherever you are. My name is Dennis McClanahan, and I am with Schlage. I am a national trainer for them. And today we're going to talk about a class called Allegion 101, Introduction to Schlage Key Systems. And if you don't know anything about it, you'll come away knowing quite a bit. And if you know a little bit about it already, then you'll go away knowing more, hopefully. So just let me introduce myself. Like I said, my name is Dennis McClanahan. I've been a locksmith for 17 years. When I say 17 years, I mean in a truck going from job to job. I've been both a commercial and a industrial locksmith, and I've worked in the industry for over 40 years total. So I've seen quite a bit, but one of the things I love about this industry is there's always room to grow, always room to know something different. So without any further ado, let's go ahead and get started. The first thing we want to talk about is our agenda today. One of the things we're going to talk about is common terms. I know the lock industry can have a language all its own. So by having these common terms, it helps you to understand that language and helps us to communicate more accurately. So when you're asking for something, I know what you're talking about. Hopefully somebody else knows what you're talking about also. Now, where possible, the terms that we're using are terms that are approved and are in the ALOA, which is the Associated Locksmiths of America. It's in their dictionary, and also Door Hardware Institute. We use theirs also. So the next thing we want to do is talk about the Schlage key systems timeline. Got to remember the Schlage has been around since basically the turn of the century. And for a long time, a lot of things didn't change. Then all of a sudden, somebody introduced something called a patented key system. And we've had quite a bit of change in the last 30, 40 years. And that's what I want to talk to you about. Also, we want to talk to you about something called key control. And key control is more than just controlling who cuts keys. It has to do with policies and tracking and a whole bunch of other things, which we'll get into. Then we're going to talk to you about something called backwards compatibility and how over the last few years and all of the different patented keys and everything, how they'll fit together and how you can use them to upgrade your security and increase your security. And then we're going to talk about how the Primus XP can be used, which is kind of a unique situation. And we'll get into it, and we'll talk about it here in a minute. Now, first, thing we want to do is talk about common terms. And when we're talking about common terms, we want to start with a cylinder. Now, the basic part of a cylinder is the plug. Now, the plug is a part that the key goes into, and it creates a link between yourself and the mechanical part of the lock, so that when you turn the key, that plug is the only thing that turns, and it engages through either a tailpiece or a cam on the back. It engages the lock and either unlocks the door or does whatever it is starts the car, whatever it is that you're doing. That plug is the first part of it. It's the most important part. Now, next to the plug, we have what's called the shell, and the shell, think about it as a pipe within a pipe. The plug is a smaller pipe. It goes in. The shell is actually the outside pipe, and it kind of helps hold everything together. Now, on top of the shell, there's something called a Bible. Now, most people, when we think of Bible, we think in religious terms. Well, Bible means a bunch of books that are together. In this particular instance, it's actually a mechanical or an engineering term, and it has to do with a bunch of objects that are held together in one place. So that's what the Bible is. Now, next, we want to talk about the keyway. Now, the keyway is real important because the keyway is what is the reason one key will fit in a lock and another one won't. And the key, it's actually cut through a process called broaching. And because of the broaching, the keyway actually runs the entire length of the plug. Hence the name, that's why it's called keyway instead of just keyhole. Whereas a keyhole is actually something different. If you've ever been in a house that's got the old-timey skeleton keys, well, the keyhole is the part that is the hole in the door that allows the key to fit into the mechanism and turn. That's a keyhole. This is a keyway. It's not a big difference, but it's something you might want to think about because it could mark you as somebody that either knows or doesn't know what they're talking about. So the next thing we want to take a look at after we've looked at the cylinder, the next integral part, of course, is the key. Now, the first part we want to talk about is the bow. Now, the bow of the key, or some people call it the head, is if it's an original key, you're going to have the manufacturer's name or either embossed or stamped in it somehow. If it's a patented key, there should be something on there that indicates it is a patented key. Now, this particular key here is a Primus, and it's got the patent number on it. If the key is part of a master key system, there'll actually be numbers stamped on the key to identify where that key fits within the hierarchy of a master key system. Another thing to remember is the bow, or the head of the key, is the part that you grab hold of. And when you put the key in the lock, if it's the right key and it turns, it creates a handle. It's a handle that you use to turn that energy from your hand into the energy that unlocks the door. So that's the bow part of the key. Also, too, if there are different keyways, usually there's a keyway. There's something on there to indicate what keyway it is. Shoulder. Now, on larger keys, you usually have a top and a bottom shoulder. Some keys don't have a bottom shoulder, and some keys don't actually need a shoulder. But what the shoulder does is actually creates a positive stop for the key. And because it creates a positive stop, we're able to cut, and we're going to find out these are called biddings here in a minute, but it creates an exact stop so that the distance between the shoulder and the center of the first cut lines up, center of the second cut lines up. It just helps everything line up correctly within the cylinder. If you've ever gotten a key that doesn't work and you have to pull it out and then it works, that's because the spacing is off, because whoever's machine, either they didn't get the shoulder stop correct, or their machine is off. But that's why it's very, very important. The next, we're going to talk about the blade of the key. Now, the blade of the key is called the blade for the very reason that it looks like a knife blade. If you look at it, it's the thinner part of the key than the head. And on top of that, we have a bottom, which if you look here, that's the bottom or the back of the key. And then you have a top, which is up here where the cuts are. Now, these are called biddings. Biddings are cuts. Collectively, they're the biddings. Individually, they're cuts. So this is the pattern that you have here of cuts, and the distance and everything determines whether or not the key is going to work, whether it's going to work in that particular cylinder. We're going to find out a little bit more about what goes on in the cylinder and how the cylinder and the key fit together to form a unit. Now, if you take that key and you look at it, if you point it straight at you and you look at it, you'll see what's called a key profile, or the key sectional profile. Just remember, that's the correct name, key sectional profile. But that profile, there are literally thousands of different key profiles, or different sizes, they're different configurations. If anybody's ever looked at a blank manufacturer's catalog like Ilco, there's like hundreds of pages of all of these different key profiles. So that's just something to keep in mind. Now, that profile will match up to a keyway. Remember, the profile is milled out, the keyway is broached, but if the milling matches the broaching on the plug, then the key will go in. If it doesn't, then the key won't go in. Very simple. Now, remember that the part of the key is called a key sectional profile, whereas the plug is called a keyway. Now that I've told you the difference, and you know that there is a difference, understand that these two terms can get used interchangeably, and don't try to correct somebody if they're not right. They'll just get mad. But they do use them as to indicate one thing. Now, next, we want to talk to you about the different types of keys there are. Now, within the industry, now these are cut keys. The first thing we want to talk to you about is something called a change key. A change key sounds like something that should actually change something, but it doesn't. All that means, it's a key that operates a single cylinder. Now, that change key operates that cylinder. It might be master keyed, it might not be master keyed, but there's only one key that fits that cylinder, and it's a change key. Next, we want to talk about master keys. Now, we heard me mention master keys here a minute ago. A master key is just that. It's a key that operates more than one cylinder. It can operate two cylinders. It can operate hundreds of thousands of cylinders. It can be part of a single tier system or a multi-tier system. There's a lot of room for expansion, but the main definition you want to take away is that it's a key that fits more than one cylinders. Now, each one of those cylinders would have an individual change key or an individual operating key, but on top of that, that master key would still work. If you think about, say, a floor on a building, and there's maybe 30 offices. Each one of those offices has an individual key, but you have a master key that will work all of those offices so that the manager doesn't have to carry around a ring of 30 different keys. Now, as kind of an interesting side note, if you're in the process of changing a master or adding a master to a system, the actual process of doing that is called master keying. You're master keying a building, you're master keying a floor, or remaster keying. So that's something to note also, that it's also a verb as well as a noun. Now, the next thing we want to talk about is key different. Key different is pretty self-explanatory because what that means is each individual lock has a different key. If you think about that in terms of, say, that office building we were speaking about a moment ago, each one of those keys, each one of those locks can be keyed differently, and that can be a good thing. The next term we want to talk about is the opposite of being keyed differently, and that's being keyed alike. If you think about, well, if you have a house that has 3 or 4 locks on it, it would be nice to have one key that would get you into each one of those 3 or 4 different entrances. If you think about like a ranch might have 20 or 30 gates on the ranch. Do you want to have a string of 30 or 30 different keys and have to go through all of them every time you pull up to a gate, or would you like one key fit all your gates? Well, that's what keyed alike means. All of those are keyed so that one key fits them. Now, the next thing we want to talk about is the key and how the cylinder works. And we've got a little video here. Let me see if I can get it pulled up. And that's it. Just a second. And here we go. Now this is the key going in. The key wave matches the broaching and the key profile. As the key goes in, you'll see that there's a lot going on there. There's a lot going on there. So let's go ahead and watch it one more time. Okay, keys going into the plug, into the cylinder. All of the keys are riding up and over the topography of the key and the key cuts. Now, if you'll notice right here, that's where the key, the shoulder of the key is, how it stops. And as it stops, it lines up with all of the different the pins and such. So let's get back to our original. If I can here. Okay, so now what we're going to take a look at now is how everything works inside of the cylinder. If you look here, you'll see that the key is not in the cylinder, and well, let's go ahead to the next slide first. When the key is actually entered, the correct key is put into the cylinder, it lifts all of the bottom pins up to what's, and all of the top pins to where the gap between the plug and the shell of the core is, and it creates a gap. Now that gap there is what's called a shear line, and when the correct key is inserted, all of these pins line up and creates a shear line. Now if you look at it here where the key isn't in, you'll see that here's the shear line right here, and all of these top pins and the bottom pins are blocking that plug from rotating. But when the correct key is put in, all of these cuts here correspond to the different size pins that are in that cylinder and lift everything up to form what's called a shear line. Now, once that shear line is achieved, then you can actually turn the cylinder will rotate, and everything works. And the world is wonderful when that happens. Let's see here. The next thing we're going to do is talk about the different parts or the different types of pins that are in this cylinder. The first thing we want to do is talk about the bottom pin. And you can always tell a bottom pin because it's rounded on one end. Now that rounding allows the pin to actually go up and over and to travel across the topography of the key so that it doesn't get stuck. If it was flat, it would get to this first part here and it would get stuck and it wouldn't go in or out. So we've got the bottom pins. Now, just a side note, the Schlage bottom pins are made out of solid nickel silver, so that they're designed to last just a little bit longer than brass pins. Now, next we're going to talk about top pins. Now, top pins are just that. They're the pins that are on top of the bottom pins. Didn't take I don't think a genius named these, but so you got the bottom pins and the top pins. The top pins are actually flat on both sides. Now they can be different sizes. They all seem to be the same size here, but they can actually be different sizes. The one thing they have in common is they sit on top of the bottom pins and they help to block the cylinder, to block the shear line if the key is not in it. Now the next thing we want to talk about is springs, because the springs help everything to seat. So once that key is going in, the springs help push the cylinder, the bottom pins down, or the whole pin stack actually down, so that they actually travel up and over the topography of the key and don't get stuck. And then when everything does line up, they make sure that the pins seat into the cuts, the flat of the cuts here. And when that happens and everything is right, then the key works. Now, one more part we want to talk about is the cap. Now, if you'll notice on a Schlage cylinder, there is a brass cap that covers the Bible and all of this. Now, during the manufacturing process, those holes are used to load the pins as part of the manufacturing process. And then that cap is put on and it's peened into place. It's not really designed to be removed in the field. If you remove it, there's about a 50-50 chance you'll be able to put it back on and peen it in. So when it comes to rekeying or changing the pins or anything, there's actually an alternative method where you have tools to use, which is a whole nother class. But if you're interested, please let me know and we'll be glad to get you on that class. Now, all of this together is it forms what's called a pin chamber. Now, the pin chamber just doesn't include just the Bible, but it also includes the plug, the entire mechanism here. And the way everything lines up perfectly, then you have a pin chamber. There again, whenever you put the key in, they slide up into the top part of the pin chamber, and then the bottom pins hopefully will align and meet that shear line, and in the bottom part of it, the plug, you're able to turn it. All right. Now, let's talk about the one little pin we didn't say nothing about. And if you noticed it, if you were sharp, you noticed that we didn't talk about this pin. We've got the top pins here, we've got the bottom pins here, but here we have another pin. Now, that pin is called a master pin. And this is the way we begin to have more than one key fit a single cylinder. So this cylinder right here has at least two keys that fit it because we have a master pin. All right? And this key here isn't the master key because, well, it could be the master key. But anyway, let's just go on. Okay, now we're going to talk about different types of cylinders. Now, what we've chosen to do here is to introduce you to something called a removable core cylinder. And you've got two different types. There are actually more types than just two. But the first two we want to talk to you about is the full-size interchangeable core, and the next one is a small format interchangeable core. Now, one of the things we've done here is we've tried to show you some of the differences. If you look at the full-size core, you'll notice right away that it's actually bigger than the small just physically larger than the small format interchangeable core. The full size utilizes a control pin, which we see right here, and when you insert the control key, it actually pulls that pin back and allows you to stick it into a cylinder. Now, a small format utilizes a second shear line for what's called a locking lug. And whenever you put the key in, it works exactly the same way. You put the key in, they both rotate about 15 degrees to the right. They retract they retract either the pin or the lug, and allows you to pull them out of the housing. Right here you can see that the full size is not symmetrical. The top is larger than the bottom. Some people call them snowmen. Then when you look at the small format core, you're looking at a figure 8, so to speak, and they are symmetrical. The top and the bottom are symmetrical. The small format has been around since 1928. A gentleman by the name of Frank Best invented it, and a lot of people call these Best style cores, but because of the fact that there's so many different manufacturers out there making them now, we prefer to call them just small format cores. Now, if you look at the control keys, you'll see that the control keys are different also. The large format has a physically larger key. Now, one of the things you'll notice if you're real observant is that there are 7 cuts on each one of these keys. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, there is a difference, however, because this last cut, this 7th cut on the full-size core, all it does is engage this pin right here. There's no, the rest of the pins, the rest of the cuts here actually engage the different top pins and bottom pins like we just saw. Whereas with this key here, whenever you put the control key in, it engages or it lifts the pins up to a separately keyed shear line, which is called the control shear line, and allows everything to work. The reason you would need a interchangeable core is if you had, say, a store, say a retail outlet that had turnover regularly, then you could actually give them a core to keep in their safe. And say if somebody quit and walked out that had a key, you could go out, pull the old core out, put the new core in, and you've effectively rekeyed the building. It works real good too in situations where you have to rekey a lot. Say, think about a college dormitory, how every year those locks have to be changed out or rotated out. By having these removable cores, it makes the process much easier. You can also stage it so you can have the cores in place and then go in and change all of them all at once. So it's a pretty handy tool to use and to have in certain situations. Now, the next thing we want to talk about is basic terminology is the different types of keys. We had mentioned, I think I had mentioned before, patented keys, and now we're going to talk about open, restricted, patented, and high security, what the difference is, and why it should matter, okay? First, we want to talk about open keys. Now, open keys are keys that have been around since the 30s. There's no restrictions on them. They're in the public domain. Any key blank manufacturer can manufacture these key blanks. There's no restriction. There's no restrictions on getting the cut or purchasing the key blanks. Anybody can do it. There's no restriction on copying the keys. If you took this key right here, which is one of our Schlage keys, and you walked into a locksmith shop or you walked into a hardware store and you gave them that key and asked them to cut it, there'd be absolutely no reason for them not to cut it because it is a completely open format. Example would be our Schlage C keyway. It's been around since the 30s. Now, next we want to talk to you about restricted. And this is where it gets a little confusing. It's not complicated, but it is confusing. With the restricted key, the factory, which is Schlage, restricts who can purchase the key blanks. So you have to be a dealer with us, or you have to have met certain criteria and agreed to treat the blanks in a certain way. Next, there's usually a signature authorization required. So you can either be an electronic signature or a paper signature, but there has to be somebody that is given control within an organization that can say, yes, cut these keys, or no, don't cut these keys. That's one of the ways that we're able to control who gets keys and be able to maintain some sort of key control. Now, a restricted key may or may not be patented, which we're going to find out about patent keys next. But when a key is patented, then there are legal safeguards that Schlage has to keep people from manufacturing the key blanks. If it's not patented, if the patent has expired, then those restrictions are just the restrictions that Schlage imposes. There's no legal way of enforcing if, say, after the patent has expired, say if a company wanted to start manufacturing the key blank, because the patent has expired, there's not really anything we can do to stop them. But because of the way we handle the keys, because of the way that the different keyways are dispersed, there are not a lot of these keys that are manufactured by the aftermarket segment. So because of that, because of the fact that we try to maintain the integrity of the key, we can help extend the life of a system and extend the protections that you have under those type. And then, of course, restrictor keys could potentially be produced by aftermarket. There again, like I said, there's nothing we can do once that patent expires. Then it's kind of it's open to whatever manufacturer wants to do. Now that we've talked about restricted keys and we've talked about whether or not they're patented, let's talk about patented keys. Well, Everest 29 is a restricted and patented keyway, but now let's talk about patented keys. Now, a patent is granted by the federal government. Now, originally, a patent was granted to protect whoever it was that developed a new invention. And what that did was allow them to recoup their investment. So they had exclusive rights to manufacture and distribute a product. But when we're talking about keys, the patent was never really meant to create a structure in which we can control who has keys. But because of the way a patent works, it does. We're able to, if a key is under patent, we have absolute rights to that key. We can say who can cut that key. We can say what process has to be in place in order for someone to get a copy of that key. So usually we have what's called a utility patent. A utility patent lasts about 20 years. So about every 10 years, we have to come out with a new patent because we understand and are anticipating the fact that whatever patent we have is not exclusive forever. It's got a time limit on it. It expires, just like your mayonnaise. So we got but the cool thing is that for the duration of the patent, though, all the keys, the cylinders, the distribution, whatever type of restrictions are put on them, we can do that. And because of that, we can maintain the integrity of a patented key system. Whereas once the patent expires, there again, it goes to open market. An example would be Everest 29 and Primus XP. The Everest 29, of course, the patent expires in 2029. The Primus XP is 2024. So now we want to talk about something called high security. And when you're talking high security, you're talking about the cylinder. You're not really talking about the key. Now, a high security cylinder is certified by Underwriters Laboratory, which means they have to go through the whole testing process. And it's a pretty grueling thing. I've been involved with a couple of UL testing processes, and it's not exciting at all. It's pretty boring because what they do is they start working on a particular product, say a cylinder, say they start drilling on it. The drill bit breaks, they stop the clock. They go to lunch, they get a new drill bit, they put the drill bit back in the chuck of the drill, have a conversation, go ahead and start drilling. And the second that drill hits the cylinder again, that's when they start the clock. Now, with the UL 437 for drill or what they call physical attack, it has to last for more than 20 minutes. But remember, that 20 minutes could include a lot of different stuff. Now, the UL 437, it has to meet those requirements in order for it to be to meet the standard of high security. So it has to be both pick and bump resistant and resistant to physical attack. And once you have that in a cylinder, then UL 437 will certify it. You'll have a certification, and then that gives you the ability to have that in, and you know that the cylinder meets those standards. So you have something to go by because you've got those standards. Now, we get our drill resistance is through the insertion of stainless steel pins, and you'll see that the pins go down right in front of the where the shear line is, and also protect the sidebar. Now, when you say stainless steel, people say, "Well, wait a minute, stainless steel isn't hardened. How can that help?" Well, if you think about the fact that this plug here is actually made of brass, which is much softer than the stainless. So what happens is those tiny little pins are enough to deflect the drill bit, and if you end up trying to force the drill bit around, that's when you start breaking drill bits. So it's really kind of a complicated process, but you end up with something that's very nice. Now also too, you'll notice there's a sidebar here. Um, on all of our products that are UL 437 listed, it has to have the sidebar, because the sidebar is what actually gives us the pick and bump resistance, which we'll go into that here in a little bit more. So the Everest 29 Primus XP UL 437, and that is the entire part number, because it is a combination of both the Primus, which is patented, and the XP, which has a sidebar. That both of those are combined in one cylinder, and then of course you have the pins which give it the drill resistance. Now we're going to start talking about the timeline, because like I said, Schlage has been around since the turn of the century. So let's take a look at the different key systems and see how they all kind of fit together. Well, the first, of course, is going to be our Schlage Classic, which is your C, E, F, G, all of those different keyways. They all have that diamond bow, and they're just really pretty. That embossing is just a very pretty way of introducing the Schlage name to you. Now, and those keys are still around. If you go out and you buy a Schlage lock and you don't specify anything other than just a normal key, you will get that Schlage Classic, which 9 times out of 10, unless you request something different, is going to be a Schlage C keyway. They're kind of ubiquitous. The only keyway that is more copied than the Schlage C keyway might be a Yale 8, but it is probably one of the Schlage C keyway is probably one of the most copied keyways. Almost every manufacturer makes a cylinder for a Schlage C keyway. Okay, next we're going to talk about our first foray into a patented system, and that would be the original Primus, the Schlage Primus. Now remember, the Primus has a sidebar we were just looking at. This is a look at a Primus, and let me go ahead and pull up an animation here and see if I can't find the Primus. And there again. Okay, here we go. And there we have the key going in. And you can see the sidebar right here. All of those keys, the pins are lining up. When the pins line up, you're able to turn it. As you can see, these cylinders, these pins right here, are just exactly the same as all the other pins that in all the other locks that we've looked at so far. The difference, of course, would be what's called the finger pins and the sidebar. There again, we're taking a good look at how everything works. You can see the way everything moves within the cylinder, and there's just a little ballet of movement that results in you being able to get into your office. Hold on a second here. Now we're just going to go back to the original. Okay. Okay, now we're back to the original. So we've seen how the Primus works. Let's go ahead. Mechanical system, Schlage C. Now, what this means here is that when we originally came out with the Primus, we made specific Primus keyways that were designed specifically for Primus, but we also made it so that like the classic keys would work in it also. So you could get it with a Schlage C keyway. Now, one of the things we want to highlight here is the undercut. These finger pins interact with an undercut, a secondary cut. You've got the cut up here that operates the other pins, the bottom pins and top pins with the springs and everything. But you also have an undercut. Now this undercut is actually done at the factory and is unique to customers and in different regions and such. So all of these pins that we're talking about here, let's go ahead and let's look at the next ones. All of these here, these are called finger pins because they got the little fingers sticking out that ride up and down on this undercut. And if it's the correct cut, there are holes that line up that allow the sidebar, which is this right here, that sidebar is actually held in place with spring tension. So when the right key is inserted, all of these little finger pins line up, and there are holes like little teeth on this sidebar that line up with these holes, and as you turn, it allows you to compress, which you'll see right here. Everything fits into a little notch right here. It allows you, the actual turning motion compresses the sidebar into the slots, into the holes in these finger pins. Now if it's the wrong key or if there's no key in it, those holes don't line up, so there's no way for this sidebar to be compressed. So it blocks the rotation of the plug within the cylinder the same way that these top pins are blocking the shear line. So it's a pretty cool little system there. And there again, like I said, we've got side bit milling, which is this undercut right here, which is done at the factory. You don't need special tools or machines or anything to do that. Then we have the finger pins, which are these things right here, and those finger pins align, if the correct key is inserted, with the teeth that are in this sidebar, and then everything works correctly. And there again, just to reiterate, the conventional pins, these parts that are up here, they work completely independently of the sidebar and that second set of cuts that are on the key. So this is the Primus. The next thing we want to talk about is, now if you notice, the Primus was introduced in 1988. Some of us are old enough to actually remember that. And it expired in 2007. So it's been expired for quite a while. But before it expired, Schlage introduced the Everest. We have Primus and now Everest. And Everest was a complete redesign and is completely different. So let's take a look at the Everest. Now remember, it came into effect in 1998, and it went from 1998 to 2014. So remember, both the Primus and the Everest, the patents have expired. So let's take a look at the Everest. Now let's see here. Let me get the right one pulled up. Oh, here we go. Let's get this one here. And okay, that's the Primus, and we'll go to the Everest. Okay, now this is the Everest 29. Okay, let's take a look. Took a little bit to get there, but here we go. Now we're going to take a look at how the Everest works. Now the first thing you'll notice is there's no sidebar. The Everest uses something called a check pin, and that check pin interacts. Let's go ahead and do that again. You'll notice we have the undercut, the same as the Primus. Now that check pin actually it's just like the finger pins, but instead of blocking the sidebar, it actually falls down into a small hole that's in the shell and blocks the rotation of the shell, just like the top pins do. Now, let's go ahead and get back to our original. Let's see. Okay. So we saw how we have a check pin here as opposed to the sidebar. Now there's our check pin, which we just talked about. There again, we have an undercut groove that is cut. There again, it's cut at the factory and is assigned to whatever system that you set up. Now, so just to reiterate, just to go back and review, we've got the check pin on the Everest. Remember, the Primus had the sidebars. We've got an undercut groove just like Primus, but instead of actuating finger pins or engaging finger pins, it engages a single pin, which is called a check pin. Remember, our purpose here wasn't in creating a high security cylinder, but just creating something different so that we could get the patent, which we did. We were able to get a patent on this. It's available in open or restricted there again, so you can get it like a Schlage key, a Schlage C key, or one of the restricted keyways, like an S or whatever. And then Primus can be added for additional security, which is, if you think about it, is really kind of cool because the part about the Primus that made it really good, that made it pick resistant, was the sidebar. And without the sidebar, you really kind of lose a lot of the pick resistance in the Everest. But because of the fact that you can put the Primus and the Everest together, so in other words, you can have a patented key with a sidebar, which is part of a system that's no longer patented, you can have that pick resistancy, and it upgrades the security of the cylinder. So just remember that you can mix and match a little bit here. Now there again, we got to look at all these patents have expiration dates, just like the mayonnaise in your refrigerator. So we've got the expiration date for the original Everest was 2014. Now before 2014 hit, we introduced something called a Primus XP. Now a Primus XP is exactly, let me go ahead and, well, we've already done the Primus, so I'm not going to show you to you again. So it has the sidebar just like the original Primus. The difference is, hold on, let me go ahead and see this here. As you can see, we have the original, this is the original Primus. It has a sidebar. In the original Primus, we had 6 different finger pins. Think of them as 6 different depths. And as you can see here, these holes, that's what the teeth and the sidebar go into when these pins are lifted to the correct height. So what we had to do is we had to come up with something different so that we could get a patent on this. So what we did was we didn't do anything drastic. We just added a 7th pin, a 7th depth. And because of that 7th depth, we had to actually come up with a new manufacturing process for the key. And because it was a deeper cut, a shallower cut in that undercut. So every Primus XP has to have at least one number 7 pin in the sidebar finger pins. So it functions just like the Primus. You've got one additional pin to choose from, but there again, you don't really get to choose because the number 7 pin has to be in all of the XP cylinders. And it is patent protected till 2024. Now, back to our timeline. As we said before, the Primus XP, the patent expires in 2024, so of course we had to come up with something new. The next thing we came up with was the Everest 29. Now, the Everest 29 is just like the old Everest, except, let's go ahead and take a look at that. If you'll notice, the key has a hole in it here. And it doesn't make it more aerodynamic or lighter or anything. All that hole does is it actually is part of the manufacturing process. Because of the fact that the pin here is actually longer and deeper, we had to come up with a different way of broaching this bottom cut. And when we did that, we ended up having to cut a hole in the head of the key. Now, let's talk about key control. Um, Key control can involve a lot of different moving parts. Um, Key control, the first part of key control is the key issuing policies. Now, when you think about key control, you need to think about things like who gets a key, who can authorize a key. If a person no longer needs a key, can you get it back? Is there a way of temporarily assigning a key? Do you let the keys leave the property, or are they held in one particular place and have to be checked out every day? There are a whole lot of different things, and depending on the size, the security level you need, these policies can be just drastically. I mean, there's just a whole lot to it. I've worked on military bases where, in order to get a key issued to a person, you have to have an officer of a certain rank authorize it. I've been in colleges where department heads can issue keys within their department, but they can't issue keys outside of their department. It just becomes a really, like I said, it just really depends on what you're doing and what you're trying to achieve. One of the things we want to talk about too is keys as status symbols. One of the hardest things to do within a key issuing or within a master key system is to make sure that only the people that need a key have a key. And a lot of people want keys that don't really need keys. Generally, your CFO or your CEO, who doesn't actually go out and do anything in the floor of the factory or part of the company, they want to have a top master key, not because they need one, but because it's kind of a status symbol. It shows how important they are. The thing you have to understand, though, is that key that they have, a top master key, depending on the side of the system, can be worth a lot of money. We actually rekeyed a major college before. The price of rekeying top down all of the buildings and everything was about $80,000. Now, if someone were to get that top master key and lose it, and you had to rekey again, that key becomes worth $80,000. And people need to understand the value of the key they have. It's not just a little bit of metal that you can get for $2 or $3, wherever you're getting it duplicated. It's the cost of what it's going to take to replace that key if it's lost. So because of that, key issuing policies become very, very important. Now, just as important as key issuing policies is a key tracking system. You have to have a way of knowing who has what keys. In small companies, it can be a notebook. Just have a notebook and a person signs for the key next to their name, and you have a list of what keys they have. When you get into larger systems, factories, colleges, military bases and such, you have to have a way of tracking all of those keys to know who has what key. Now, as important as tracking those keys is also auditing the keys. Now, from time to time, most major companies will do what's called a key audit. Because they have a tracking system, they have a list of what keys each person is supposed to have, they can go to that person and say, hey, show me your key ring. And they can do an audit of the individual keys that person has. Now, there again, like we said when we were talking about the stamping on keys, you can have the master key stamp on it, so you can look at what keys are stamped and whether or not if they have a master key that they're not supposed to have. But in addition to that, you can actually serialize the keys. You can get keys with serial numbers on them so that it's not just a master key, it's that particular master key that is issued to that person. So there's a lot involved in tracking. Now, as important as tracking is also retrieving the keys. Now, when a person is let go from a facility, all of the company property is retrieved from that person before they get their last paycheck. And one of the pieces of property that person might have in their possession is a key. Do you just let that key go with that person? Or do you have a place or a checkbox on an exit interview that says retrieve all keys? Because if you have a patented system and you can retrieve all of the keys that were issued, then you still have the integrity of that system is still in place. It hasn't, you know where all of the keys are. Now, next, we're talking about using a patented key system. We've kind of talked about this quite a bit lately, but let's just go back and reiterate. If the system is patented, then the manufacturer can control who gets a key, or who has access to the cylinders, who has access to the key blanks. We can put in place different procedures like key authorization forms and such to as far as who gets to cut those keys. And because of that, we can maintain the integrity of the key. You know that if you give a person a key and you get that key back, that they haven't had any other keys cut. On top of that, now after the patented system, the next best thing, of course, is a restricted system. If you've got a patented system and the patent has expired, please know that we're going to do everything we can to protect your investment and make sure that those restricted keys now are treated just as if the patent still exists. And but basically, you're going to extend the life of your key system. Now, why is key control important? Well, we've kind of talked about that a little bit. The prevention of unauthorized duplication of keys. I had an experience with the school system. The school system was a fairly small school system. It was very rural, and they only had about 10 schools, including elementaries, middle, and high school within the whole county. But they were experiencing loss. They had computers that were disappearing. So because it was an interchangeable core system on the school system, what we did was we staged and had new keys, patented keys, cut for all of the schools, and we had new cores keyed up and everything, so that over the summer, the maintenance guys were able to go in and take all of the old non-patented keys out of the system, out of the school system, and replace them with new patented keys. Well, the beginning of the next school year, the teachers were issued their new keys. Within 2 days, the teachers union had filed a grievance against the school system. And the reason for the grievance was that with the old keys, the teachers were able to go and have multiple copies made so they could put on all their different key rings, and whatever car they drove, they had a key to their classroom. And oh, by the way, if they lost a key, that wasn't a big deal because they had plenty of other keys to have copied. So that over the years, all of these keys had been cut and lost. Teachers had come and gone, and all of these keys, there was no way of knowing how many keys were out there to fit any particular classroom. So it was kind of no wonder that there was getting a lot of loss. So when they switched to a patented system, they couldn't have these extra keys cut. And while it required a lot more thinking on the teacher's part, it increased the security of the school incredibly. There was no unauthorized duplications. Every key that was out there, if a teacher left and they got that key back, they knew there wasn't a dozen keys out there that somebody had. And then, of course, reduce the number of undocumented keys. Unauthorized and undocumented keys to me is kind of the same thing. But when you get undocumented, you can actually have authorized keys cut, but if they're not documented, then you're kind of defeating the purpose of having the restricted keys in the first place. But because of the fact that, there again, Schlage requires key authorizations before we can cut, it eliminates all of those unauthorized or undocumented keys. And because of that, you increase security. Whenever you have key control, you're getting keys back from the people that you're giving them to. The person only has the level of key that they need. You're able to track who has what keys. It makes everything. It makes the whole facility more secure. It makes everything more secure. Now we're going to get kind of going with our we talked a little bit about the different generations of keys. We had the Primus, if you remember, then we had the Everest, then we had the Primus XP, and now we have the Everest 29. And we're going to talk about something called backwards compatibility and what that can do for you. Right here, we're looking at the original Everest. It was created the patent was started in 1994. Patent expired in 2014. We have the A, B, and C families of keys. Now, remember that doesn't mean that there's only 3 keys for Everest. It just means that Within the B, you have like the B123, the 124, 125. So you have a lot of different families of keys underneath each one of these initials. Now, of course, the Everest is no longer patented, so we had to come up with the Everest 29. Now, with the Everest 29, we have new keyways. We have the R, S, and T. And as you'll see right here, you have a C123 and you have an S123, and they kind of correspond. If you'll see the way we've got these numbers here we've got these letters, not numbers, set on the screen, you can see that the B and the R key are within a family, but the B will not fit the R. So the old keys will not fit the new patented key system. However, one of the things we did was we made it so that the new keys will fit the old system. So even though a B won't go into an R, the R key will go into a B key. So if you look right here and you see that you've got a C123 here and you've got an S123 here, the key that fits this S123 cylinder will go into the C123. Now, what does that mean? What does that do for you? Well, think about the fact that, say, if you had an Everest system and you had hundreds of cylinders, the cost to change out those cylinders would be pretty substantial. But if you were to, say, replace the cylinders on the exterior doors of your facility with the Everest 29, say if you had the C keyway, the C123 in your existing facility, you replaced the exterior doors with the Everest 29 with the S123, then you could recut all of the keys within your system here on the S123 blank. And there again, the blank is what's controlled here. This key is what's controlled. So even though the Schlage Everest system is no longer patented, you would be able to replace all of those non-patented keys with patented keys and extend the life of your system out. So it was kind of an interesting thing that we were able to do that. Somebody was thinking. Now, how can you remember we had talked about how that you have the high security key and you have the Everest 29, which doesn't really have a lot of pick resistancy to it, but the Primus XP does. So how can we use the fact that you can combine the Everest and the XP together so that you have a patented key that expires in 2029 with the Primus pick resistancy that you get with the sidebar? So let's take a look here at a real life situation. We've got an office here and we've got 8 doors. 2 of those doors are exterior doors and the other 6 doors are interior doors. You've got a master key that works all of the doors. Each one of your offices is keyed different, and it's on an S123, which we've already determined that S123 is an Everest 29 keyway. And the customer wants to upgrade the security. Now, we're not upgrading the patent, we're upgrading the security on this particular facility. Now, what could we do? Well, let's take a look at, okay, which doors could you use to add the security? Now, if you'll notice, we kind of slipped, we did a little trick here. One of the offices has been eliminated and it's been turned into something called a company vault. You'll find secure rooms in a lot of different companies because you'll have proprietary information, you'll have new products, R&D information like that, and it's stored in a secured room. You can call it a vault, but the fact that it's being called a vault means that something important or valuable is being stored there. So let's go ahead and take a look, and okay, these offices can stay the same. We don't have to replace the cylinders in these offices because we don't need to upgrade security on them. But if we were to take and combine the Everest 29 key with the Primus XP cylinders, a sidebar, now you have a pick resistancy that you're able to put on the exterior door. So you've upgraded the security of that particular door. And if you'll notice, the CEO, well, he's important. He has to have that XP. He has to have that same level of security. Now, because of the way it's set up, now hold on, let's just go ahead and take a look and see what we do. Look at that. We've got the Vault. The company Vault is using an XP UL437. So remember, the whole part name for that is a Everest 29 Primus XP UL437. And basically, it's a combination of just like these right here, you have a combination of the Everest key and the Primus sidebar. And on this particular one here, we've added the pins for the drill resistancy. So it's pick resistant and it's drill resistant. You've had a drastic upgrade of the security here just by replacing 4 of the 8 cylinders. Now, because of the fact that it's backwards compatible, let's go back here. Because of the fact that it's backwards compatible, if you wanted to, if say these internal office keys here fit this door, so say the parking lot's right here, and you wanted the office key to fit this particular door, you could still do it. Now you would have to recut the key for the office on the new cylinder, on the new key, because remember we've got those extra cuts that the finger pin uses on the sidebar. So you'd have to recut their keys, but you could key it up so that their key would fit this door and their office, and hopefully the toilet too. You wouldn't want to lock them out of that, but you don't have to. And there again, you can make them carry 2 keys if you wanted, and that increase the security. Wouldn't really be increasing the security, but you wouldn't have to have that keyed that way. But because of the fact that you can recut keys, even though you haven't replaced the cylinders, you can upgrade their security, upgrade the key that you give them. They can still have the convenience that they wanted or that they need, but you've upgraded the security on that particular facility, and you've only replaced a few of the cylinders. Now, that's how you can get the XP and how everything kind of fits together. Hopefully that makes sense to you. But just to reiterate, we talked about terminology to begin with. We talked about the cylinder, the plug, the core, the plug, the cylinder housing, the shell, the Bible. We talked about keys, the bows, the blade, the bitting, and hopefully you've got a little bit better understanding now. We talked about the Primus XP and how it's got the sidebar. And because it does have that sidebar, you can incorporate that sidebar even in the Everest if you want. We talked about the Everest 29. There again, XP 2024 is when the patent expires there. Everest 29 is a lot easier to remember because it's in the name, 2029. Key control, we talked about the key issuing policies, about having the ability to track the keys, the use of patented keys and cylinders, the difference between patented and restricted, and what that means to you, and how you can't really use an open keyway if you really want to have any kind of key control, because there's no way of controlling who can cut those keys. That's basically it for our seminar. Oh my goodness, I forgot tiered. You have tiered security. If you remember the real world example, how that we had a UL437 on one particular door, we had the pick resistancy added to the exterior doors in the office for the manager, but the original offices in the bathroom, they didn't need that same level of security. Not all doors are created equal, and so you don't need to spend the same amount of money securing the bathroom that you do the company vault. So by having tiered security, you're able to save money. Now, there again, there's some resources that we would like you to be aware of. If you want more information about key systems, we have the Allegion.com. You can just follow that link right there. It'll take you to catalogs. You can look at the key systems, and it does a pretty good job of showing you what's available to you. Also, too, if you go to Allegion.com, key systems, it'll take you there. Remember the key systems. When you go to Allegion.com, there's a tab there that is training, and you would be able to take more courses like this. In fact, you've probably used that tab to get to this right here, but it will be available to you. Also, too, there's a blog that we have called idighardware.com. That is awesome. as a locksmith that was in the field, you would get told things. Oh, well, you're not allowed to do that, or no, we can do that, but it depends on the occupancy. If you have a question about codes, about NFPA 101, about NFPA 80, any of that, you can go to iDig Hardware. You can ask the question, and they will get back with you and answer the question, so that you don't have to guess. Of course, a lot of the questions come back, or a lot of the answers come back. Well, it depends. Of course, you always have what they call the authority having jurisdiction. But when it comes to the actual specifications and the actual codes themselves, it's a great resource to have, and I encourage everybody to take advantage of that if you have any questions. Also, customer care, we can't forget about those guys. Those people, they know a lot. If you have any questions, you can call customer care, and they will take care of you.